Hello, Professor Elliott again, and in this video I will review with you some sample uh, timer circuits for the 555. Okay, in this arrangement, this is being used as an oscillator, and the oscillation frequency is determined by resistors R1, R2, and C2. Okay. Yeah, all right. Anyway, sorry, mind wandered for a second. Capacitor C1, that's just recommended on the manufacturer's application note to put a 0.01 microfarad capacitor between pin 5, which is the control input, and ground. It's just for more stable operation. That's all. Okay. Next page. So here's what you see here. And this is the output waveform, which this I did in multi-sim. And one day I'll have to do it on the real scope now that I have one. But anyway, so notice that the high time TH is much wider than the low time TL. I have the reasons for this explained on another presentation, but basically it's because it's not possible to have the same charging discharging times for those external resistance and capacitors, so therefore the high and low times can never be equal. In this case, the high time is much wider than the low time, so this means the duty cycle, which is the ratio of TH to the period, will exceed 50%. So in this case, the output frequency is 33 kilohertz. Okay. So here I'm just using the cursors to measure the high time and measure the low time, and then calculate out the duty cycle. So this is the period, this is the high time, which is just this bit in here, and it's 75%, which if you look at it, it appears about correct. Okay, so the 555 is a square wave oscillator. There's slight variances, but roughly the power supply voltages run from +5 to +15. Check the data sheet, but that's ballpark what it is. Okay, but it gives you a square wave out. And yes, you could use this if you powered it with 5 volts to make a TTL compatible oscillator. Add a small signal diode. It's important that it's a small signal, not a power diode, something like an IN914, because it turns on and off much quicker. And in this configuration, then this shortens the discharge time, because when the capacitor discharges, it'll discharge basically through R2 because it's being bypassed by that diode. So what we're using this for is we're changing the duty cycles. Okay, so if we need an oscillator that has a duty cycle that's less than 50%, we simply add that diode in. Now the low time TL is much broader than the high time TH, measure the frequency in the periods with the cursors. Okay, and then calculate the duty cycle, which in this case is 24%. So we can either have the duty cycle less than 50% or more than 50%. It's impossible to make it exactly 50. Okay. All right. Okay. So this says the calculated load time may be determined by, and this is from the application note, TL, this bit in here, is approximately equal to 0.694, some reasons say 693, does it matter? No. Times R2 times C2, or 32.62. I measured it at 34.47. That's very close. Okay. This is called a one-stable, or stable, a one-shot or a monostable, which is used on a trigger pulse. You hit it, and then the output goes high for a period of time. Something along the lines, if you've ever used a timing relay, something along those lines. In this case, then, we have one external resistor, RA, an external capacitor, and then we're providing a 25 kilohertz TTL clock, and that's called the trigger. It's important to know that if you're working with this, that the output pulse is triggered only on the falling edge. So this is the trigger. This is coming from a function generator or another circuit, and see on this falling edge here, right? That means the output, which was normally low, is then going to switch high, and it'll stay high for the duration of time as determined by this formula. So that external resistor and capacitor, that's what's setting that time period. And then when that time expires, the output goes back low again, and then it has to wait until the next falling edge trigger pulse. So it's a monostable, otherwise known as a one-shot, and when you hit it with the falling edge trigger pulse, the output goes high for a certain amount of time and then goes back low again, waits for the next cycle. Okay, and that's just a little bit blown up view of that. Okay, thanks very kindly. Catch you later. Bye.